You are learning multi-threading. How many ways to create multi-thread application? 2 ways. What is first one? Extending java.lang.thread class. Second one, implementing java.lang.runnable interface. Okay. 2 threads you have seen. Any Python students are there? This is Java class. This is Java class. New students are there? Python students? No. See, there are 2 ways to create a multi-thread application. First one, by extending java.lang.thread class. Second one, by implementing java.lang.runnable interface. See, how many steps are there to create multi-thread application? 7 steps. Suppose, according to steps, what is the first step? Create a class that extends java.lang.thread class. This is the first step. What is second step? Override run method. Third step, any task. Suppose I equal to 1, I less than or equal to 10, I plus plus, system.out.println, suppose child thread plus I. Now sleep time, suppose thread.sleep, suppose 1000 milliseconds. It will throw exception, compulsory try catch blocks. System.err.println e. It is common. First step, create a class that extends java.lang.thread class. That is over. Second step, override run method. That is over. Third step, write child thread task code. Over. What is fourth step? Write main method. Public static void main. Next step, create an object of current class. Which is current class? Demo class. Next step, call start method. What we will write? d.start. Next step, write child thread task, main thread task code. Suppose same task I'll copy. Same task I'll copy here. Here just child thread place main thread I'll write. Okay. Now file, save. See, Java C demo.java. Java demo. So like this, child thread, main thread, child thread, main thread, both are running simultaneously. Okay. Now here, now child thread, main thread, child thread, main thread, like this printing. Now what I want is, whenever main thread value is 5, I want to suspend child thread. Whenever main thread value is 5, I want to suspend child thread. What we have to write? Here, if, what we have to write? Whenever main thread value is 5, I want to suspend child thread. If I double equal to 5. What we have to write? Suspend method you have to call. Suspend method in which class? Thread class. Now, can I call demo reference? Demo is a subclass of thread class. That's what we can access. So what we have to write? D dot suspend. Okay. Now, when I compile, what will be happen? Just you observe. Compilation. We are getting one warning. It is not error. You observe. It is warning. One warning. So suspend in thread has been deprecated and marked for removal. So this method they are planning to remove from library. This method they are planning to remove from library. That's what they are saying. Don't use this method in real-time projects. Okay. But it works. See. Some issues will be there. That's what they are planning to remove. Now, if you can run, that is warning only, not error. See, whenever main thread value is 5, child will be suspended. See, main is running, but child is stopped. Child suspended. When suspended thread will start again? Whenever resume method is called. I given life cycle, no? Suspended thread will start whenever resume method is called. This is a life cycle diagram. See, while running, suspended. After that, resume. So, until you call resume method, suspended thread will not start. Okay. Now, I want to resume. Whenever I value 10, I want to resume. If I double equal to 10, D dot resume. Okay. Now, file, save. Compilation, execution. See, both are marked for removal. So, marked for removal. They are planning to remove in future libraries. So, Java demo. When main thread value 5, child suspended. What is happened? You observe. Main also not working, you observe. But previously worked on no? This type of issues will be there. That is the reason only they are planning to remove. See, now actually I suspended child thread. But what is happened? Main also not running. You observe. See, not running. Again I'll execute. See, main is running. I didn't change, no? I didn't compile also. I executed one more time. Now it is running. See, previously not worked. Now it is working, no? These type of issues will be there. That is the reason they are planning to remove. Okay. See, Java demo. Now it is running. Whenever main value 10, child started. Whenever main value 5, child suspended. Whenever main value 10, child started. This is suspend resume method demonstration. Now, note down. Program to demonstrate suspend and resume methods. Program to demonstrate suspend and resume methods. Program to demonstrate suspend and resume methods. Order. Doubt. Is it over? See, In this program, how many threads are there? 2 threads are there. Okay, multi-threading. Now, whenever main thread value is 5, child thread suspended. Whenever main thread value is 10, child thread started again. Now, I want to suspend main thread. How to suspend main thread? Now, D dot suspend. That means which thread suspended? Child thread or main thread? Child thread. I want to suspend main thread. What we have to write? Let it suspend. How will write? Only suspend. Now, D dot suspend means child suspended or main suspended? Child suspended. I want to suspend main thread. What we have to write? Now in this program, 2 threads are there. Which thread I suspended? Child thread suspended. I want to suspend main thread. Not possible. This dot suspend. This dot suspend. Is it valid here? Why it is not valid? Static method does not refer this and super keywords in any way. Study no? So this is error. How to suspend main thread? I want to suspend main thread. Thread dot suspend. Is it suspend method static method? Is it static? So non-static. How can you write? It is not possible. No? Thread dot suspend is error. It is non-static method. Instance method. You cannot call with class name. Give me answers. I want to suspend main thread. Possible or not possible? If it is possible, how? If not possible, why? Not possible, why? It is child thread reference. Main thread reference you can call no? Not possible. Why it is not possible? Child? From main thread if you suspend, child suspended. But is it not possible to suspend main thread? Think yourself. If I create one more object, one more thread will be created. If I create one more object, one more thread will be created. I want to suspend main thread. Possible or not possible? If possible, how it is possible? What we have to write? If not possible, why? Super keyword. Super keyword if I write super class thread suspended. Super keyword if I write super keyword, is it possible here writing super? No. Static method, this and super keywords not referred. Doesn't refer. Think yourself and give me answer. If not possible also I want answer. Why? Main thread suspend, main thread reference use. The D nothing but which thread reference? Child reference. Like that main thread reference. Main thread reference not there. Think yourself and give answer. Only suspend also not possible. Only suspend can we write? No. Static method doesn't refer this keyword. Implicitly also not possible. Explicitly also not possible. Recently you studied current thread. Day before yesterday. Current thread method you studied, no? The method wherever you call, that thread comes. Current thread method. Study, no? Now, thread T equal to thread dot current thread. If you write, which is current thread? Main thread. With the T, we can call suspend, no? Possible. Okay. So, possible. See, here, what I'll do is thread T equal to thread dot current thread. Now, here we got a reference, no? It is which class, which thread reference? Main thread reference or child thread reference? Main thread. With this T, can I call suspend? Yes or no? Yes. We can suspend. Where we are downcasting. There is no upcasting, there is no downcasting. Now, so current thread. It is static method. I am calling with thread dot, class name dot. It is current thread reference. Which is current thread? Main thread. Main thread suspended. See. File, save. See, that is warning only. See, main suspended, child running. Child running, main suspended. Now, see it is child, main suspended. Then, here, resume method, how will call? Suppose. Now, this a problem will occur, you observe. If I write like this, now, here, when say D dot suspend means here execution suspended, but T dot suspend means here only suspended. Then, if I write here any other line, suppose something if I write, is it executed whenever it is suspended? No. If I write resume also, no use. That thread will not start if you suspend main. That's what we should not suspend main. Now, if you suspend, how to resume the thread? Now, whenever main value 5, main only suspended. Now, how to resume the thread? This is not possible. Suspend possible, resume not possible. Got your point? Suppose here I'll write here if I double equal to 10. Okay. Now the T dot resume, if I call, will it work? Control will never come to here once if it is suspended. Got your point? When this line is executed, execution stopped there only. It will never come to next line. See, for example, now class is running. Okay. One person will go out. Class will run or not? 2 members will go out. Myself, I'll go out. Like that. So, main thread we should not suspend. Main is suspend means resume not possible. Okay. Child n number of you can suspend. Main is suspend means no use. Like that. Okay. Now, That's what we should not suspend main thread. Suspending possible, but no use. As in resume not possible. See, is it clear? Understood? We should not suspend main. 5 members, if we go out also, class will run. Myself, if I go out, class will not run, no? Like that. Okay? Now, there are 2 ways to create thread. Next way, I'll show you. Next, write it. Steps to create a multi-threaded application steps to create a multi-thread application by implementing java.lang.runnable interface. Steps to create multi-threaded application by implementing java.lang.runnable interface. Steps to create a multi-thread application by implementing java.lang.runnable interface. First step, create a class that implements java.lang.runnable interface. Create a class that implements java.lang.runnable interface. Second step, override run method. Because here also run method is there. That method only we overridden in previous programs also. Write child thread task code in a run method. Write child thread task code in a run method. Next, write main method. Create a class that implements java.lang.runnable interface. First step, override run method. Second step, write child thread task code in a run method. Write main method. Here somewhat different. These all steps same now. Previous also, now also same. Create an object of current class and assign to runnable reference. Create an object of current class and assign to runnable reference. Next, create an object of current of thread class by passing runnable reference. Create an object of thread class by passing runnable reference in thread class constructor. Create an object of thread class by passing runnable reference in thread class constructor. Create an object of thread class by passing runnable reference in thread class constructor. Call start method. Next, write main thread task code in main method. Steps to create a multi-threaded application by implementing java.lang.runnable interface. These are the steps. Create a class that implements java.lang.runnable interface, override run method, write child thread task code in run method, write main method, create an object of current class and assign to runnable reference, create an object of thread class by passing runnable reference in thread class consider, call start method, write main thread task code. Okay. See. First code snippet I'll give. Now, just a template type I'll give. First, what we have to write? First step, create a class that implements java.lang.runnable interface. What we have to write? Class demo implements runnable. Is it required to import java.lang package? No. Second, override run method. What do you write? Public void run. Next step, write child thread task code. Okay, this is child thread task code. Next, public static void main. String args. Now give me answer. What we have to write? Give me answer. Create an object of current class and assign to runnable reference. See that line? Fifth step. Create an object of current class and assign to runnable reference. What we have to write? Give me answer. Runnable or equal to new runnable possible new demo. Okay. So runnable or equal to new demo. Say create an object of current class. Which class object created? Demo class only, current class no. Demo class object created. Assigned to runnable reference. Okay. Next step. Create an object of thread class by passing runnable reference in thread class constructor. What do you write? Create an object of thread class by passing runnable reference in thread class constructor. Thread equal to new thread R. That's it. Okay. So thread T equal to new thread R. Now, is it considered or not? I passed what I passed? Runnable reference. So that's what I given two constructors. You observe. Two constructors are there, no? Thread default constructor is there. Thread which takes runnable reference. I given notes. You can see two constructors I given. This constructor required now, which takes runnable. What is next step? Call start method. How to call? What is that? R dot start. R is interface. T dot start. Start method where it is? Thread class. The thread reference is there, no? Previously demo reference. But now demo class implements runnable. Runnable is interface. Now with the demo reference also not possible. With runnable reference also not possible. Because the method is available in thread class. Previously extends thread. That is the reason with the demo also possible. Now T dot start. After that main thread task code. Here how it is multi-threading I'll show you. See, first of all main method called. Now, first of all, main method called. See, first of all, main method called. Okay. After this, open brace. After this, open brace. After this, control comes here. Runnable R equal to new demo. Demo class consider called. Is there any demo class consider? No. Will it Java compiler provides? Yes. In that constructor, what will be there? First line? Super. What that super will do? Super class constructor. Which is super class? Is it class? No. Super class I am asking. Where is thread? Which is super class? Object class. Runnable is interface. Runnable is not a class, no? But which is super class? Object class. But where is extends object? Implicitly. You studied every class implicitly not dead. So object class constructor called. That means thread is not created. When thread is created, thread class constructor. That's what in this line, child thread not created. Next line. Here which class constructor called? Now here thread will born. But in previous program, new demo time only thread will born. Because in previous program, demo extends thread. But that's what here in this line created. New thread will born. Okay. New thread will born. Now child thread, main thread. This is child. This is main. Okay. Now start. Start calls run method. Control comes here. Control comes here. Control comes here. This is executed. At the same time, this thread, it comes here. It is executed. Whatever you write here, it is passed to output window. Whatever you write here, it is also passed to output window. Both will send. Here you'll get it, output window. See, here, this is child thread. This is child thread. This is main thread. Here, this is child thread task code. This is main thread task code. Sorry, this is child thread task code. That is main thread. Child thread task code. This is main thread task code. Okay, write this one. Writing program little bit different. Only 2 steps different. Remaining all same. Over. Is it over? So whenever thread class constructor is called, then child thread will born. When start method is called, thread will be ready. Start implicitly calls run method. Then thread will run. Okay. Is it over? So whatever you write here, both will run simultaneously. It will send the output to output window. This will send the output to output window. Whichever comes first, that will print first. That's what output we cannot predict. Which is going to come, we cannot predict. Okay. It is child thread task code. It is main thread task code. Now see how to write. We'll see now. According to steps, what is the first step? Create a class that implements java.lang.runnable interface. What we have to write? Class demo implements runnable. It is first step. Is it required to import the lang package? No. Why? Default, implicitly imported. Next step, override run method. Next, write child thread task code. Just I am printing core Java. Okay. Suppose every 2 seconds. Sleep method, instance method or class method? Class method. That is the reason I am calling with class name. Will it throw exception? That is the reason catch block. Try catch. First step completed, second step completed, third step completed. Fourth step, main method. Fourth step also completed. Next step, create an object of current class and assign to runnable reference. What do you write? Runnable R equal to new demo. Next, create an object of thread class by passing runnable reference in thread class constructor. What do you write? Thread T equal to new thread of R. Next, call start method. T dot start. Task. Main thread task code. I'll copy this one. I'll paste here. Here, just in the place of core Java, I'll print advanced Java. Here, I'll write 1 second. Okay. Advanced Java 1 second, core Java 2 seconds. file, save. See, advanced Java printed for every second, core Java printed every 2 seconds. Both are running simultaneously. See, advanced Java completed, core Java running. It is completed. Now I want to write one more thread, but content different content. Then object creation record or class record? Class. Suppose one more class. Class test. Implements runnable. Next. Public void run. Next. Task. Task I'll write same task. Here just I'll print Java double E. In the place of core Java here, Java double E I'll write. It will wait every 3 seconds. 3 seconds it will sleep. Now, what we have write here, if you want to call that thread, that is that thread code I written. I want to start. What do you write? Create an again object you have to create, no? Which class? Test class. What do you have to write? Runnable R2 equal to new test. Next thread T2 equal to new thread of R2. Next T2 dot start. Same style. Okay. Here we written 3 lines, no? That is only these 3 lines. Now 3 threads are there now. Now core Java, advanced Java, Java double E. So advanced Java every second, core Java every 2 seconds, Java double E every 3 seconds. See, advanced Java completed, core Java, Java double E running, core Java also completed. Now only Java double E running. Okay, like this. Multiple threads. It is one more way. I'm not done. Why 2 ways? I'll explain. First write this one. It's an example. Not over. Two classes are there, test class, demo class. Now in this program, two classes are there, test class, demo class. In this program, how many classes are there? Two classes. How many threads are there? Three threads are there. Okay, three threads. One is printing core Java, one is printing advanced Java, one is printing Java EE. But first of all, why two ways are there to create a thread? That is required. Now, first, is it over? Suppose class A, okay, class A extends, suppose class A, it's one class. Class B extends A, it is there. Now, in this class, for this class, I want to write multi-threaded application. Class B extends A. In this class, multi-threaded application, I want to write. How many ways to create multi-threaded application? 2 ways. What are those? By extend java.lang.thread class, by implementing java.lang.runnable interface. Class B extends A already is there. Can we extend thread class? Can we extend? No. That is the reason. One more way. Implements runnable. So here extends thread A, extends thread you cannot write no. Extends A already is there. You cannot extend one more class. In that situation, implements runnable. Okay. Already you studied interfaces. What purpose introduced? Multiple inheritance. But extends A is there. Extend thread not possible. Implements runnable possible because multiple inheritance. Okay. That is the reason only 2 ways. N number of we can create, but maximum 10 only better. Now, next concept, synchronization. Next heading, synchronization. It is a mechanism that allows to access a shared resource only one thread at a time. It is a mechanism that allows to access a shared resource only one thread at a time. It is a mechanism that allows to access a shared resource only one thread at a time. See, if many threads are there, if many threads comes to access a resource, shared resource at a time, if you want to allow one by one, in that situation, this concept required. For example, it is the best example to understand. 5 computers are there. Already given this concept while teaching string buffer. Now 5 computers connected together as a one network. Now I want to use printer. How many printers required? 1 printer or 5 printers? 1 printer enough. Okay, because already network. So 5 printers not required. So 1 printer. Printer. I'll connect to this computer. Now, can I take printout from here? Can I take printout from here? Yes, you can take here also. From here also. From here also. Now, printer is a one resource. Printer is a resource. Can I call shared resource? Yes, because this can be shared by among all clients. So all systems can use the same printer. So it is a resource. It is a shared resource. It is not specific to this computer, not specific to this computer. All computers can use the same printer. Shared resource. These are like a threads. 5 requests comes. 5 requests at a time comes to printer. Will it print all at a time? Like a multi-threading output comes? No. Because that is synchronized. Allows one by one. See, what is happened in multi-threading you have seen. Core Java, Advanced Java, Java EE like that. All content at multiple time. Output window one only. Content is mixed, no? Like a multi-threading, if output comes, this content, this person content, this person, all content is mixed. Okay? Like a multi-threading output. Like that output, if it is printed, that is wasted. That paper you have to throw in dustbin only. Wasted. So, 5 requests comes at a time, but it allows one by one. That is synchronization, which allows one by one. Some applications synchronization required. Some applications synchronization not required. Depends upon situation. See, in this case, printer software, it is synchronized. That's what it allows one by one. Now, google.com website is there. The website, can I call shared resource? Google.com, not person, not particular one person, you know. Worldwide crores of people can use. That is shared resource. Worldwide crores of people, they'll send the request to Google server. Now, will it process all at a time or one by one? At a time or one by one? At a time. If it is synchronized, what will happen? For opening Google homepage also, half an hour you have to wait. Okay. So their synchronization not required. Here synchronization required. Like that situation. Now how to synchronize? Next node. There are two ways to synchronize the code. First one, synchronizing a method. Second one, synchronizing a block of code. First one, synchronizing a method. Syntax. So just one keyword we have to attach. Synchronized. Synchronizing a method. See, if many requests comes to access this code, if many requests comes to access this method, what will happen is, whichever first came, that is entered, allowed. After whenever it will come out, then second thread started. Again, whenever it will come out, third thread started. Whenever it will come out, fourth thread started. Like that. It allows one by one. But how it is working? Just one keyword. I'm not going to do anything. One keyword I'll attach. Then if many requests comes, allows one by one. Okay. This is one way. One more way, synchronizing a block of code. Synchronizing a block of code. Syntax. Synchronizing a block of code. That means your complete code is not synchronized. Only these two lines synchronized. If complete code synchronization required, first way you have to use synchronizing a method. Only one line, two lines like that, very few lines are there, block. Your object class object, any subclass object you can pass. So now, suppose if many threads comes at a time to call this method, then what will happen is all allowed at a time up to here. Up to here allowed. So all threads at a time allowed up to here. But only this part is synchronized. Now, suppose this came first, it will enter. When it will come out, this will enter. When it will come out, this will enter. Whenever it will come out, this will enter. So this part only synchronized. So complete method body if required, you have to use synchronizing a method. Only one line, two lines required, synchronizing a block. This program, next class we'll see. Tomorrow I'm not coming. I'm leaving out of station. So next class on Monday. Okay. Tomorrow no class. Next class on Monday. So next class on Monday, 7:30 we'll see. So tomorrow no class.